All right, kids, we're going to do little linear inequalities today. First, we'll go fairly quickly here. We're going to cover this in class as well. To determine if an ordered pair is a solution, of course, all you have to do is plug in, right? Take the 3, plug it in for x, take the 4, plug it in for y, and you just want to see if you end up with a true statement. Is 2 less than 3? Of course it is. So 3 comma 4 is a solution. There's an infinite number of solutions, but there's also an infinite number of wrong solutions. But that's all you're doing. Here, this one, we plug in the 0. This one's a little bit different, right? Is 0 bigger than 0? It's not, right? So that's not a solution. And then this one ends up being yes. You can do that one yourself. Okay. But all you have to do is plug in to verify. All right, to determine if something's a solution. Now, most of what we're going to be doing is we're going to be doing some graphs. Okay, now remember, we can think of this as slope-intercept form, like y equals, even though it's an inequality. But remember, y in a plane number would be a horizontal line. We go down to the -3, and we would draw that horizontal line. Now, what this says, though, is y is greater than or equal to -3. The or equal to means that anything on this line is good, because anything on this line, the y value is -3, and -3 is equal to -3. But it also says that y could be greater than. Of course, greater than means above, so we would shade up here. And this shading would go forever in the up direction, right? So the line is solid because of this line underneath, okay? The or equal to. Anything on that line is equal to -3, so it's good. Anything above the line is good. Anything below is no good. Now let's do this one. X in a plane number is a 1, 2, 3, 4, 5, is a vertical line. But this line we have to draw dashed, okay? And I'll explain why in just a second. You see, this just says x is less than. It just says plane less than. If we were to make this line solid, a solid line means that anything on the line is good. But anything on this line, the value of x is 5. 5 is not less than 5. So we do a dashed line instead, because it's just, whenever it's plane less than or plane greater than, we do a dashed line, because that line itself is not part of the answer. It's just the border. Now here, it says x is smaller than 5. Where does x get smaller? X gets smaller to the left, so we would shade to the left. That's it. Down here with these two down on the bottom, we just graph this like normal. There's the -3 up 2 over 1. We'll do that a few times. Let me go backwards. And then remember, it's plane greater than, so we're going to draw a dashed line. And it says y is greater than. Y gets bigger in the upwards direction, so we would shade above the line. But the line itself is not part of the answer. Any point here works. -1, up 1, 2, 3, 4 over 1. Let's go backwards. Down 1, 2, 3, 4, left 1. This is also a dashed line. And this is y is less than. Less than means you got to get smaller. Okay? And that's kind of the gist of it. I'm going to do a few more over here on this document. This is the same exact type of thing. Remember, our quadrants, if you forgot your quadrants, this is the first quadrant. This is the second quadrant. This is the third quadrant. And this is the fourth quadrant. Okay. Go down to -3. There it is. Up 1 over 2, up 1 over 2, up 1 over 2. Let's go backwards. This is going to be a solid line because it's greater than or equal to. That means any point on the line is good. It says y is greater than, so that means shade above. So we would be up here. And notice how our shading is actually in all four quadrants. It has the first quadrant, second quadrant, it doesn't have a lot of the fourth quadrant, but it does have part of it. And the boundary line is solid, which means it's included. So this would be, you're picking from one of these things down here. You would pick E, and then on the back side of the sheet for number 1, you would write an E. All four quadrants includes boundary line. Here you'd have to do a little solving, right? You'd have to subtract x. So this would be y is greater than negative x plus 1. There's the plus 1. Negative x means negative 1, right? Down 1 over 1, down 1 over 1. I'll go backwards a little bit. Here I have to draw a dashed line because it's plain old what? Plain old greater than right here. So I would shade above because it's greater than, and it's a dashed line. So that's, what are we? We are in quadrants 1, 2, and 4, excluding the boundary line. It looks like it should be S. So I hope you get the idea of this. I'm not going to do all of these. I'll do a couple more though, so you get the idea with this. Number 4 is a little bit more involved, right? So I'll go ahead and do that one. You would have to subtract 3x from both sides. So you would get 2y is less than negative 3x plus 6. Divide by 2. Y is less than negative 3 halves x plus 3. So there's the plus 3. Remember, our slope is down 3 over 2, down 3 over 2, down 3 over 2. I draw a dashed line because of the plane less than, and it's less than, so I have to shade below. So it looks like I'm in all four quadrants. I'm only in quadrant 1 a little bit, but I'm still in there. So all four quadrants and excluding the line. You see, because the line's dashed. I'm going to do number 7. And this one here, you'd have to subtract 2x from both sides. So I have negative 3y is less than negative 2x plus 12. Divide. Now you got to be careful here. That's why I'm doing this one. So a couple things to keep in mind, right? First of all, we have to change this direction because we're dividing by a negative, so that's greater than. These negatives cancel, and that would be a minus 4. So I'm down there, up 2 over 3, up 2 over 3. This would be a dashed line, and we're greater than, so we're going to shade above. So I'm in all four quadrants. I think you know what? I think I might have made a mistake here. Let's see here. Negative 2x. Oh. All right, so I got to find my mistake here because no. Subtract 2x. I did that. Negative 3y divided by negative. We switch this direction to greater. Oh, it's greater than or equal. See this should have the line underneath it. So that should be a solid line. I was just going too fast there. So greater than or equal to, that would be, whoops, all four quadrants, including the boundary line. Okay, so I'm hoping you get the idea here. I'm going to do just one more. Here we'd have to distribute. We'd get 2x minus 2y is greater than or equal to 5. If I move the 2x over, I would get negative 2y is greater than or equal to negative 2x because I have to move that over by subtracting. When I divide by -2, similar to the one we just did, I have to switch that direction to less than, and that would be, and here you actually get -5/2, which is -2.5. That's okay. You're just going to be in this in-between zone. Up 1 over 1, up 1 over 1, up 1 over 1. Down 1, left 1. This would be a solid line as well. And we have to shade below. So it looks like we're in quadrants 1, 3, and 4 with this included line. So that would be A. Okay, if you want to do this on your own, this thing should come out to this. Their father was a boar. Okay?